Hello everyone. I'm going to go over homework 4 and hopefully try to answer your questions before you start to ask them. So this is a really important homework assignment. It's going to be the first time where you are designing a south end of your totem, and that's going to match up with one of your partner's north ends. So you're going to have to take your drawing and send that off to someone, and you're going to have to receive a drawing from someone for you to be able to design your totems. So, as it says, it is critical to let your totem partners above and below you, know about design changes that may need to be made or that have been made. And your goal is to design the south end with accordance to the partner's north end. So it's important here, and we'll get into this a bit into more detail, is that the south end that you design does not need to and should not be a negative of your partner's north end. And we'll get to that in just a sec. But basically, we want to just match the width mating feature. And we're going to do so with a tolerance of 5 thousandths and an allowance of 2 thousandths. And so we'll get into that as well. So we can talk to our partners and get their drawing. In this case, I will be Stan Marsh, and I have to go get my drawing from Kenny, who sends it as a PDF. He does not send the part or the drawing file. You just need to send the PDFs to your partners. And so I, as Stan, have received this file. And so I need to make a south end of my totem match the precision fit, this 580 thousandths width feature. So now I'll show you how I like to create a new revision. It's not the only way you can do it, but it works for me. So if I want to create a new revision, you can see I have my part name here is Crazy Part R0 for revision 0. And I have a drawing associated with it. So I'm just going to copy paste and rename the files. So we have revision 1, and we'll rename this. We will copy, paste, and rename that to revision 1. Now we can open up our drawing, and you can see we have our drawing made for our part. And what we want to do is go up here and under the drawing tab and replace model, because right now this is still referencing the revision 0 model. So we can hit replace model. We want to select our views, so we'll select our primary view here. You'll see if you click one of these, it actually has a little crossed out thing, and if we click it, it says it's a derived view because we place the front view first, then the top, then the side. So you just have to click that first view you put down, and then also any isometric views, and you can see now we have view 1 and view 5. So we're going to replace these with a new model. So we can then go to New Model, Part Assembly, Browse, and we can pick the new file we just copy pasted and renamed, which is Crazy Part R1. So we can open that. We see everything's green since we haven't changed anything in terms of the part itself yet. And we'll make sure to save. And now we're ready to go. So we can start to go in, and first thing we want to do is update our revision number and add the names for the people for the north and south mates. The south mate, so we can enter Kenny's name. So let's just use Kyle's name. All right. Next thing we need to do, make sure we update our revision number and update the date. And we can exit out of our title block and save. And now we're good to go. We're ready to start designing our south end to mate with Kenny's north end. So we have our part here. In this case, this is our updated revision part that we haven't modified yet, but now we're going to go ahead and go to the south end, get lined up on that, and we're going to extrude a cut because we want to cut away everything except for what's going to be close to a little rectangle that just mates with that 0.580 dimension. We don't want to mate with the flat sides on the outside or the 1/4 inch hole there, or even the radius that we can see here. We just want to mate with the 3 decimal place precision fit. So let's go ahead and convert entities to get the edge of the circle in, and then we can just sort of freehand our shape in. Go ahead and close it off and then make that for construction. I'm going to trim entities and trim away that bottom bit, so we're now trimming everything but this rectangle. And you can see now we have everything locked in. We just need to set the width. So we can see 0.580 plus 5 minus 0. So at the smallest this can be is 0.580. It can't be any smaller than that. And so what we want is for our piece to be no larger than 0.580 minus the allowance. So that 2/1000ths allowance that's listed here just means that this width needs to be 0.580, and then it needs to be no larger than 2/1000ths smaller than that. So we can write that as 0.580 minus 0.002, which gets us obviously, I'll show it here, 3 decimal places, 0.578. So that's how we're going to model it, and when we do the drawing, we're going to say it can be 0.578 plus 0 minus 0.005. And in that way, we ensure that this will always fit that part, and even at max material condition, we're going to end up with a 2/1000ths slip fit. So now that we have that dimensioned, we can see we're fully defined. So you can exit out of that. And now we want to extrude our cut. So we can look and see that that's 200,000ths depth. And so you don't, this is where it doesn't really matter how deep you can go. You can go just 100,000ths deep if you want, or you can go deeper, but then your part's going to be sitting up proud a little bit. So I'm just going to go let's go 150,000ths. Well, now that we have our part created, let's go ahead and make the drawing for it. So if you remember, we already had our drawing created when we copied it. So that's going to be our Crazy Part Revision 1 drawing. And since we updated the reference, you can immediately see that we have everything updated here, and it hasn't quite updated correctly, so that's fine. We will get rid of the things that didn't come across correctly, and we'll update them. Get our smart dimension back in. And now we also need our south view. So if we right click our primary view, actually if we click the box, and we can do projected view, and then we can pull down the projected view oriented in the correct way. We can turn off the hidden lines so we don't get confused, and same up here on this top view, we'll turn off the hidden lines for the south end features on the north view and turn off the hidden lines for the north end features on the south view, just to keep things a bit more clear. We also need to put in our center lines, so we'll go ahead and put those back in and make sure they are long enough. That one looks okay. And we'll extend it just a little bit. And now we lost our center mark. We never had it there, so we'll add in the center mark. And now we're going to put in our precision fit. So we can go back up to tolerance precision, choose bilateral. Let's get 3 decimal place precision. And we want this part to be no wider than 0.578. Again, that is 2/1000 smaller than this at its narrowest. And we want to be able to allow this to be even smaller by up to 0.005 of an inch. So as you can see, we have +0, -5, and over on Kenny's part, we have +5, -0. Now what we still need here is the south isometric view. Which we have already saved. So now we have the south isometric view, so we get a nice idea what's going on there. So that's Stan's drawing completed, so you can now save as PDF and submit it for his Memo 4 assignment. And so each of you will need to do that, communicate, and create your south ends to mate with your partner's north end. At this point, if you're unsure about why we're putting this 2/1000 allowance, we have the 5/1000 tolerance and then a 2/1000 allowance. That's the 0.580 minus 0.578 will give us 2/1000. I'll go ahead and give you a bit more of a 3D visualization of what that is. So here we are in an assembly view. You guys won't be able to do this since you won't have your partner's CAD file, but this is just to help show you what that 2/1000 allowance allows us to have. So right now I have these parts mated with the planes there, so they're lined up that way as well as this way, so that means their central axes are aligned, and we can adjust this height. Let's bring this down to something a bit closer, so you can see they will start to engage with each other and nothing else is going to be getting in the way. And we can go all the way to bring those all the way together. And now if we take a section view right here, we can see here we have just a little bit of Stan's part and the entirety of Kenny's part here. And you can see how we created a width mating feature that just mates with the 0.58 tolerance. And we can also zoom in and you can see there's a very small gap. So if we measure the width of that gap, between those two faces, between Stan and Kenny's parts, we find that the distance is 1/1000th of an inch. So that 1/1000th of an inch plus the 1/1000th of an inch on the other side is the 2/1000ths of an inch that we have listed here as an allowance. So these CAD parts are drawn at max material condition, so they will never be larger than this. This piece will never be larger, and this gap for the 0.58 will never be smaller. So worst case scenario, you have a 1/1000th of an inch on either side to fit. Well, hopefully that helped you guys out and cleared up any questions that you may have for Memo 4. And so good luck.